Oh, there it is. Thank you. Well, I have to say, this is pretty nerve-wracking. I have been working on this for the last 3 years, and now I'm standing in Cloudflare, who is a big DNS provider, talking about this, which is in front of a bunch of people who know way more about Rust than I do, so it's a little intimidating, to say the least. Before I start, I have to start with a safe harbor agreement with you guys. This is legalese, but I am not here representing my employer. I do not work on this project for my employer. This is a side project, a total hobby project for me. So I just want to make that clear, and I will not be talking about my employer at this. Oops, back. I'm also not a security expert by any means. I've learned way more about security by working on this project than I knew before, which is kind of fun. I also have no connection with Cloudflare, though thank you very much, Cloudflare, for hosting this. I appreciate that, and also for 1.1.1. I have no connection with Google, Mozilla, or Quad9, though we do have configs that are related to a lot of those guys, so I just want to make that clear. Okay. Before I thank all of these people, it's important to thank my lovely wife, who's at home right now putting both of my kids to bed and let me come out and do this. So she's awesome. Thank you, Lindsay. I need to thank everybody on this list because none of this would have been possible without the hard work that's gone into, first, the language, which I have sadly not contributed a line to at all, and I'm very sad about that, but I haven't had time to get all of that. I only have about 2 hours every night to work on this stuff. And that's maximum. The Tokyo and Futures work, I have gotten to contribute a little bit to this where I had some minor problems. But these have been excellent for all the async stuff that goes on in the library. OpenSSL, I know it gets a lot of hate, but if you've looked at the recent code in the C library, it's actually pretty good. But all of the contributors there and also the bindings in Rust are really nice. The Ring library is amazing for anybody who hasn't used it yet, and Brian Smith is leading a really awesome effort there. I highly suggest checking that out. All of the DNS RFC authors, as much as I disliked some of the articles that I had to read and how confusing they were, the work that went into all of that is pretty amazing. And then obviously, all of my contributors, when I first put this together, there were 25. There are now 27, and thank you very much. If anybody's in this room has contributed to the library, thank you. And then especially to all the users who've thrown all caution to the wind, decided to use my little hobby project, and don't care whether or not their DNS actually resolves to anything. Thank you. Okay. Like Steve said, I think it's fun to talk about what gets people into Rust. And I read this article about 3 years ago when Aaron Turin put it together. There was so much in here that caught my attention as an engineer for over the last, well, when this was written, 15 years professionally, where I had dealt with every problem that this article said was not a problem in Rust. It was just kind of mind-boggling. It hooked me in. I immediately decided I have to figure out, I have to learn about this language, and I have to start working with it. So as I became a Rustacean, I think everybody in this room who started and now knows Rust has become a fearless programmer like me. In fact, when I go to any other language, I no longer have any confidence that it's doing what I expect it to do because Rust has given me so much confidence. So I'm now a worse programmer in every other language. I guess that's a thank you, Rust. I don't know. So I really wanted to learn the language, and I needed to pull something down substantial in order to do that. For me, I took a look at the ecosystem when I was starting out, and I didn't really notice much going on in the DNS area. There was a couple of things, but I decided right about that time, Bind 9 had some major security announcement. And I was like, well, why shouldn't DNS be written in Rust? I think a good question at this point is, why should I write DNS in Rust? The center of the Rust universe is over here. This is my little diagram up here. Center of the DNS universe is over here. I'm somewhere around here. I don't know Rust. I've used DNS in the past on some infrastructure projects. In fact, a buddy of mine, Paul's here, who I worked with on that. And I had a fairly narrow view of what you can use DNS for, although from my experience with it, I wanted it to be way better. Dynamic DNS has always been kind of faulty, in my opinion, and so I really wanted to focus on that. So I started, of course, at the beginning, and started reading every RFC. I started implementing all of these RFCs, starting with the basics, moving on to the dynamic DNS, moving into DNSSEC. DNSSEC was really hard. I don't recommend ever doing that. And also, nobody apparently wants to use it, so we can talk about that later. Anyway, so was it worthwhile? Who knows? But the reason I really thought all of this stuff would be really interesting is, from my experience, like I said, dynamic DNS was always really interesting to me. You have an authority sitting out here, and you have some computer, and you want to be able to inject records into it, and you want to be able to control your DNS. You may want to direct people to different areas on the internet based on some of that. So my pure interest in all of this has always been, I want to make this authority trustworthy. I want it to be able to deliver secure packets so that people can trust what's coming back from it. And I want it to be easily configurable and easily manageable. What I keep imagining here is, why isn't DNS being used for more things? Why is HTTP the crown jewel of the internet? I've never completely understood that. But anyway, so that's why I'm working on this. But it turns out, for most people, what they want is to find out how to get to their photo site and figure out how to load stuff from that. This wasn't a big goal of mine, but I kept getting all these questions. Hey, how do I do A record lookups? How do I do quad A record lookups? How do I deal with this stupid CNAME thing that's coming back from the server instead of the actual A and quad A records? And I was like, well, what you're asking for is a resolver, and I haven't implemented a resolver. I've only implemented this client, and it's capable of communicating with this. So after explaining that over and over and over again, I was like, okay, you guys want a resolver, I get it. Totally hear you. So I started working on a project, the TrustDNS resolver. I was like, this is only going to take a couple of weeks, right? I mean, it can't be that hard. And the stub resolvers are responsible for communicating with your recursive resolver, and Cloudflare runs this nice one now, which is kind of cool. The recursive resolver is responsible for doing some magic. I haven't built that part yet, so I couldn't get into the details of exactly how that works, but just imagine lots of graph traversals and going back to other cached nodes out there and everything, until it finally gets to your authority that has the zone records for your example.com. So that's kind of, this is the picture of DNS. So about a year later now, I have, right, 2 weeks, a year, I finally have something that I would be happy for anybody in this room to use. It may not have the best ergonomics, but I definitely appreciate the usage if people do it. That stub resolver now can give you your A records and your quad A records, or whatever it is you want to look up, and it properly does all the CNAME chaining and everything else that you might need. So that's the TrustDNS resolver. That's what we're talking about today. This is a little graph of what you get when you actually build something that people want. So this is about 3 months ago. Before this, when things weren't working quite as well as they are now, it wasn't getting much usage. Then the H2 library came out, and Joe Wilm posted this on the announcement in the Reddit pages, where he said, hey, we don't have an asynchronous DNS resolver in this H2 example that you guys have posted. So I implemented one, and I posted an example of it. And all of a sudden, right about that point, that was 3 months ago, approximately, maybe a little bit more now. All of a sudden, everybody started using this. And this is really what happens when you give users what they want. They actually start using your software, which is kind of cool. And I think that number is now up to 20,000, I checked today. So that's fun. So thank you. This is why I actually work on the software. It's fun seeing these numbers go up and up and up. Anyway, that reminds me of my favorite computer scientist, who's Dijkstra. Every time I read anything from Dijkstra, I just feel like he's speaking directly to me about my career and what I do. But I love this quote, that you can't, a program's like a poem, you can't write a poem without writing it, which is almost Zen. I put the article here because when you actually punch this into Google, you'll only get back quote sites instead of the actual document. But this document's great to read. It was a transcription, I think, of a letter of his from years ago, written in like 1982. But the entire premise of this article, and I think it's important to the Rust community, is you have to build software to know how it's going to work. You can't go around telling people, hey, your software is going to work better if you build it in Rust. If you just rewrite this in Rust, all your problems are going to go away. You have to show people that that's true. And I hope with the stuff that I've done, I might actually be showing people that, because I'm not a systems programmer. The last time I actually wrote for a company any systems software was in 2001 about. Some Corba stuff. Nobody even uses Corba anymore, sadly. I moved on to gRPC, which somebody can explain the difference to me, I'd love it. But anyway, but Corba's dead. I stopped using C++ about that time, and I never went back. I started using Java. I had no intention of ever touching C or C++ again at that point. It's just too painful. If you've ever had to debug stir without a proper null terminated stream, you wouldn't either. Anyway, so I thought at this point it would be good to actually show some code, because this is a Rust meetup, and I find that everybody shows code at these things, so hope you guys are following along at this point. What I wanted to show is just 2 examples. I had 3, and then I kind of practiced this talk, and it was going to be way too long if I tried to walk through 3. But the 2 examples that I have here are, one is multiple IP lookup strategies. This is an interesting demonstration of why the futures library is actually pretty cool. Futures are going to be changing substantially in the next couple of releases with the async stuff that's going on and everything. So I don't know, if you haven't started on futures, maybe you want to wait a little bit, I don't know. For the lookup strategies in DNS, as we've moved into an era where everything's IPv6 and IPv4, it's become important to be able to deliver either address. Now, in my opinion, if you care about which type of IP address you are getting and using, then you're doing something wrong. You shouldn't care whether you're getting IPv4 or IPv6. You should just be trying to connect to a server upstream. But sometimes people do, and I got some feedback for that. Because originally, I had started with what's known as the, God, can't remember the name of it right now. Happy Eyeballs, thank you. The Happy Eyeballs RFC, which is, I think, IPv4 and IPv6, according to these strategies. And when I had released that, I immediately got some feedback that it was a little confusing for people because they didn't know what IP address they were going to be getting back first, and they didn't know how to deal with that. So I gave in. So now the default is first to look for IPv4 and then look for IPv6. I would prefer it to be the other way, and I'd love feedback from people if they find that to be different. But anyway, so this is just the enum that defines our strategies. I'm not going to do a tremendously deep thing, code walkthrough here. We're going to just skip through. a bunch. So this is the happy eyeballs. And what I wanted to show here is not the boxes. You'll see a lot of boxes in my software. I regretfully am here to inform you that I am a true believer in making something work before you make it correct and well before you make it fast. And most of my libraries are now in somewhere on the order of make it correct. So you'll see a lot of boxing. And I'm probably not going to remove these for a while because I might as well just move to Infiltrate, which is pretty awesome and got released today with 1.26, which I'm very excited about. So if we look at this in a couple of months, this will all look different. But anyway, the point is we're looking at futures. And the futures library has a bunch of nice combinators, much like iterators, right? So you do the host lookup. You can do a single A record lookup and a quad A lookup. You do this select on it. It would seem natural that you'd want to do a join here because you're doing an AND, but really you want this to succeed whether or not one of them fails. So even though it's an AND, you're technically hoping that one of them succeeds even if the other one's not there. So that's what this is doing. It's doing a select. It's then passing that into a then, and then we just deal with some of the errors. It's a little wordy. There's probably a better way to do it. Like I said, I'm not a great Rust programmer. And then this is just an example of one of the other strategies, which is IPv4 and then IPv6. And the only difference here is that we're not doing a select now. We're first doing a lookup, and I made this function generic over either IPv4 first or IPv6 first. So there's actually a higher order function that flips between those depending on your settings. And then this just does the host lookup and then does the then. The reason that host lookup isn't, what that function does, I should have said that earlier, is it first looks in your host file to see whether or not your name is defined in there and returns that first if it's there. Otherwise, you drop down through and you might have some errors and continue on some other lookup chains. Anyway, so that's, I think, a fun example of how combinators work in futures. We'll see what that stuff looks like as the async, the new async features start landing. I have no idea how that's going to look, but I'm excited for them and also a little trepidatious because it means a lot of work to refactor all of this, but anyway. So the next example here is how we deal with CNAME and SRV chaining. If you're not familiar with SRV, it's a service record. It's instead of just a standard A record in your DNS, SRV allows you to associate a port as well, which can be very handy. A lot of people still assume what port they actually need to connect to on a server. That's if you're running anything in a data center, that's kind of no longer true, especially if you're in Kubernetes. And actually, there's a whole bunch of networking stuff that goes on in Kubernetes that I personally think could just be offered with DNS, but that's me. Okay, so this is literally just iterator logic. So there's no futures work going on here. What this code example has is at the very beginning, we've gotten a response from an upstream server, or maybe multiple upstream servers, because we might have done one of our selects and gotten IPv4 and IPv6 back. So that's why there's multiple messages associated with that. We then flatten that into just pulling out the answers from those messages. And in DNS, you have 3 fields associated to a message. You have your answers section, you have an additional section, and then you have a name servers or authorities section that comes after that. And for the RFCs, the only place that I should be looking at this point is in the answers section. So that's what we're doing here. So we pull all the answers out, and then Brian Smith came in and refactored this for me because I was doing a lot more cloning before. So he added the cow borrowed. So you can thank Brian for a little less allocation here. But anyway, what this is doing is folding all of those answers into a final result where we're looking for any CNAME or SRV chains. And actually, there should only be one first record in SRV, but I'm not enforcing that. So if that annoys you, you'll have to file a PR. For the CNAMEs, though, what we're doing is we're just iterating over the entire set of answers that we got in those messages until we fold them down into just the final CNAME that we're looking for. Does that make sense? Is everybody following? Is this boring? Yeah, sorry? Was there a question? So after we find those CNAMEs, what we jump into is actually grabbing the records that you're looking for. So what we've done there is we've gone back. Let me just flip back for a second. What we've done is we've followed a chain of records all the way down to the last CNAME record that might exist in these messages. And we folded that down to just one name now. And also a TTL and some other things like, was it a CNAME? So this is actually our final result. What was the search name? What's the final TTL that we would have calculated from that whole chain, which is going to be the minimum TTL of the entire chain? And then this is just a nice little flag that tells us whether or not we started with a CNAME. And that'll come in, that's important later. So anyway, what we do is we then combine all of our answers and our additionals. If it was a CNAME record that had come back in this response, that may exist in the additional section. And that kind of is up to whatever server you're connecting to. It's supposed to be in additionals, but I don't really care. If it's in answers or additionals, it's fine with me. We pull the answers into an iterator. We do a chain on the additionals. We then filter this down to, and I've simplified these if statements a little bit for this talk because they are somewhat large, but they're enforcing that the name is equal, that our query type that we're searching for is equal, and this is the original query type that you're looking for. So if this was an A record, then what we're looking for is now the A record, or it's an any search. So you actually ask DNS to get any record that you could possibly find. And otherwise, it's an SRV record, and we do a slightly different lookup here. But finally, after we filter that down to just the names that we're looking for, we do a collect right into a vector that has all of those records in it. And at this point, we should have the final A records or quad A records or whatever it was that you were looking for in our results, which is cool. But sometimes you don't get all your records. And sometimes you're dealing with an authority upstream that's actually too simple and it's not capable of giving you additional sections with your actual A records in them. And so we have to check for that. We have to say, hey, did we actually get anything returned? If so, if our records aren't empty, then we get to just return our async ready and here's all the records that we found. Otherwise, I'm not going to explain all the object types. There's a whole bunch of layered objects here for futures and other things, but anyway. So that first one is just returning our records. The next one is if it was a CNAME and we didn't find all the records, then what we know at this point is that we didn't get the final record in that initial response. And so what we have to do is do a recursive query. And so this actually fires off an additional query out to the internet or your network to do another lookup. And then that gets kind of goes through the whole cycle again. So there is a cap. I think I've capped it to a maximum of 8 lookups for any single resolution period before it'll give up. Anyway, if we get to the end and we're still not able to find anything, then we essentially return an error. Sorry, not an error, but an NX domain, meaning that we weren't able to find it. Which isn't an error, you can see. It's actually an okay, and everything's good at that point. It's okay that the servers didn't respond. What you didn't get was a network error, and that's handled through an entirely different set of logic. Anyway, that's just two examples of how I think Rust helps with building of DNS. But I thought, since I was going to be here at Cloudflare, we could talk about one last thing. And this is something that I'm kind of excited to announce, that in the 0.9 release, when it's coming, we'll now have, oops, I don't think you guys had the font that I was using. That blue should be a little to the left. Anyway, you now have a resolver configuration that allows you to use TLS with Cloudflare, which, so you can now use TLS with the TrustDNS resolver. I built DNS over TLS into the libraries about a year ago, almost immediately after the RFC was complete, but nobody had implemented it anywhere, so I never figured it was worth putting it into the resolver until Cloudflare made its announcement, and also Quad 9. So you can either use Cloudflare Quad 9, or you can just join those together and use both if you want. It doesn't matter. Although I bet the Cloudflare people would like it if you just use Cloudflare. But anyway, this is feature flagged off, mostly because it pulls in either OpenSSL or your native TLS libraries or the Ring libraries. I have support for both OpenSSL and native TLS, and then also Russells. I would recommend using Russells for the easiest path if you're going to use this, mostly because it all gets compiled in statically and you don't have to worry about your build chains too much. The other one would be native TLS. If you try to use OpenSSL directly, you have to go through a bit more configuration because you have to pass in things like CAs and all sorts of other stuff. Anyway, but what about DNS over HTTPS? I don't have a lot of use for this because I'm working on software. I'm not working in a browser. I think this is pretty valuable to people who are working inside browsers. And you need the endpoint that you're communicating with to also speak HTTPS and encapsulate all of that in HTTP packets. And for me, I don't have a need for that. If people want to add this to the library, it would be pretty easy. With the H2 library, it should be fairly easy to wrap all the other TLS stuff that's already been built into the H2 library. And if somebody wants to do that and contribute it back, I'd be happy to accept it. But for me right now, the only way that I see this being valuable is if you're actually inside of a browser section. And until I hear somebody's using TrustDNS inside of a browser, like I haven't integrated it into Servo or anything, but that would be cool. So until then, I don't really see much need for implementing this in the library. But anyway, that's it. I would just want to thank you guys for listening. I hope that was interesting to you. You can contact me at any of these addresses, email, Twitter, Reddit, GitHub. And I'll happily respond through whatever means you contact, and happy to answer any questions if you guys have any. Yeah. Thank you.
Questions?
So I noticed that you use a lot of return from a function, and while like the statement return, so you don't have to put in the explicit return keyword. I don't actually remember what it's called, but like how worried are you that eventually you add some code after those blocks, and then your function will be silently returning the wrong value? Does that make any sense?
It does?
Yeah.
Maybe you could explain it.
So this is something I've hated about lots of programming language, the implicit return. The value of the last statement is what gets returned. Rust actually does it well, and I found it works very well. If I accidentally put an extra line in, it won't compile because the previous one doesn't have a semicolon. And so yeah, but I've never made that mistake because of that convention of the semicolon. The absence of the semicolon only makes sense on the last line.
But you could have like something, you could in theory have like a if, you know, something, and then you return a value, or as part of a match, for example.
No, because within the block, I have to leave off the semicolon if I'm going to get a return value out of it. So I have if, you know, foo, then else bar. If I have a semicolon, I get a unit return. If I don't, I get the value. If I add an extra line, that won't compile anymore. I have to put a semicolon at the end of those lines.
I completely agree with that, that answer. Yeah. Yes. Yeah, it's, I initially, when I came to Rust, I actually didn't use that convention a lot. And specifically because from other languages, I was very worried about what would happen. But yeah, the compiler catches all of that for you. I've never made a mistake in Rust with that. Yes, Perl. We're not defending Perl here, are we? Good.
Hi, thanks for the talk. It was really cool.
Yeah.
I'm interested to hear a little bit more about your motivation to build this. You talked a lot about kind of using it as a proving ground for how Rust could do it better. I'm curious about what sort of applications you have in mind for yourself once this gets to a more or less stable state.
Sure.
How do you intend to use TrustDNS's libraries?
Yes. When I started the project, I have to say, I didn't know how I wanted to use it. And I started learning more about DNS the more I got into DNS, which makes sense, right? The more that you know something, the more you know how you might want to do, what you want to do with it. Initially, all of my experience with DNS was all, like I had said, mainly from this infrastructure project that I had been working on, where DNS was a substantive problem and hard to manage, and it was hard to distribute records to a lot of different DNS servers if you had them on a network, and all sorts of other dynamic problems when you were trying to dynamically configure it a lot. So that was my initial motivation, was just to come into it, and what I wanted was a very good client library initially. The server aspect of it was going to generally be simple from my initial standpoint. So a lot of it was around that dynamic stuff. And so I added some features to the client library initially that I found were missing in almost every other client library that I've ever seen. So things like atomic adds and atomic replaces and all of those features, which DNS supports in all of the RFCs, but I've never seen client libraries that actually implement that. Obviously, you're relying on the server properly enforcing that for you, but those were my initial reasons. As I've built all of this, like I was saying earlier, in that picture, I actually think we can do a lot more with DNS and in kind of IoT type spaces. And this library can't get to, you know, thumbnail size IoT devices, at least not in its current state. We'd have to do a lot of work to slim it down. But for, you know, bricks and things of that size, I think it would be really interesting to see what we could do with DNS in that realm. One of the things that I added somewhat recently was multicast DNS support and DNS service discovery support, specifically so that we might be able to do applications like IoT style things. But for my next thing that I want to work on and distribute a library for, since the resolver is now in a pretty decent state, I want to merge that into the authority code that I've written and build a server that we can run as daemons on any machine, and then use that for doing all of our DNS lookups. So you can now have a secure and you know, use DNS over TLS on any platform that you want to deploy this on. One of the things that I dropped from the talk was actually a feature that might be bad, actually, from other people's perspective, but from my perspective, I think it's kind of cool, which is that in the resolver, I built in a performance kind of some statistics to monitor just success and failures of any DNS server that you're using upstream, and it will reorder those servers based on which one's performing the best. Eventually, I want to add latency as a measurement into that, and I haven't for no good reason. I haven't had time to get back into it and add that, but so at that point I feel like the library itself could start being used more for applications like lookups on anybody's machine. Does that answer your question? Anybody else? Cool. Thank you very much.
Thanks, Ben. I think the quote there, Ben, was make it work. Was it make it work, then make it fast? No, make it work, make it complete, then make it fast. So we don't have the make it complete presentation, I think, but we have make it fast coming. Arushi, bring up the next talk.